actually on.
Yeah, we think you can hear us and see us.
Yes,
yeah.
We are here, and so just in case, I'm going to test. Yes, okay, I'm being told to stop. That means we are definitely working, and we took a vote. We are pretty sure we are much better at building amazing PC handheld gaming devices than we are putting on a virtual conference. We've been workshopping a new streaming part of this event, so thank you for joining us in this experiment.
And thanks for sticking with us. Yep.
Yeah.
A couple things to mention. The Q&A function is now running, so you can ask questions and you can also upvote questions. So if you see something that you want to see answered, give it an upvote. And one thing to mention about that is that we're going to be taking a look at all of the questions that are most upvoted, and we'll answer them in the specific talk Q&A that it most clearly applies to. And if we don't get to it then, we'll get to it at the end of the day.
Okay, and you may be wondering, but this schedule doesn't seem to match what it was before. You are correct, but don't worry, we are still planning on having all of the talks happen in the order that they are scheduled on the left-hand side of your screen there, so you can anticipate that being the schedule we follow from here on out. And I feel confident.
Super confident.
Confident.
So for just about the third time today, I'm going to introduce Lawrence Yang. He's a designer on the Steam Deck team, and he's been working on the Devkit program, and he has some really helpful tips to share on how to test your games for Steam Deck, even if you don't have a Devkit. Lawrence?
Hi, my name is Lawrence, and I'm a designer on the Steam Deck team. So at this point, we've sent hundreds of dev kits out to developers around the world, and we'll have another wave of kits available soon. So if you haven't already filled out the request form on the partner site, please do so. However, even with this latest wave of dev kits, we unfortunately won't have enough to serve the entire developer community. And that's the main reason for this talk, is how do we get around this problem? How do you develop for Steam Deck without a dev kit? So right off the bat, there are a few really quick avenues you could take. If you have a friend with a dev kit, you could always ask them to try your title and give you feedback. Or you could go to the Steam Deck developer forums and ask one of the developers there who has a dev kit whether they can check your title out. So this is useful, but be warned, this is just going to give you a snapshot of how your title performs right now. And you won't really be able to iterate on it unless you have a really good friend with a dev kit. So a better option would be to actually test your title for yourself with hardware you have available to you. And it turns out you can do quite a bit without a dev kit. So just as an aside, we have gotten a lot of questions about dev kits and whether there's anything special about them, whether there's any special hardware or software or bits that make it easier to develop for. And the answer to that is no. It's just a regular retail prototype unit, and there's no extra bits to it. So a lot of the testing you'll want to do for Steam Deck, you can actually do with hardware you have available. So let's go by the main pillars of the Deck Verified program and see how you can test various pieces of your title for Steam Deck compatibility. First up is input. So your game should have full controller support, should use the appropriate icons and glyphs when on screen, and automatically bring up the on-screen keyboard if you ever need to input text. Testing this is really simple. Just plug a controller into your computer and play your game. So I have a PS4 controller here. This is a great option because it has a lot of the same inputs as Steam Deck, including a trackpad and gyro controls. But you can also use an Xbox controller, you can use a Steam controller, you can even use a Switch Pro controller. Anything that connects to Steam you can use to test for controller support. And while you're playing your game using a controller, take note of moments where you might reach for your keyboard or mouse, because those are moments where our testers will be noting that down as well, especially in places like launchers, for instance. If you don't already have a default controller configuration for your title, we highly recommend you make one. And one way you can do this is to look at the top community controller configurations and try them out. You can use them as templates for setting up your own intuitive control scheme and set it as the developer default, and you'll be set. If you want to learn more about improving input support for your title, don't forget to check out Scott Dalton's Steam Input Talk. Next up is display. So your game will need to support Steam Deck's default resolution of 1280 by 800, or 1280 by 720 also works. It should be performant at the default settings and should have legible text on a 7-inch screen. So there's a couple really low-tech ways to check this out. You can set your game to 1280 by 800 and make sure that it still works. You could resize your game window down to 7 inches across on your monitor and see whether the text is still legible. And you get bonus points if you can actually do all of these at the same time. So if you want to replicate what it will look like for an end user, you can actually find hardware online that will do this. So for instance, This baby monitor is 7 inches across and is 1280 by 800. This was $73, and it's a really good way to test for Steam Deck legibility because it's basically the same screen, or at least the same specs. Any monitor around this size that supports 720p will work, though. So that's an option. Next up is system support. So this is the most involved item from a homemade standpoint, and the reason is the best way to know how your game will run on Steam Deck's Linux-based OS is to actually test it in a Linux environment. So at a high level, what you're going to want to do is install Linux on a machine, install Steam, and then run your game using Proton. Or if you have a native Linux build, just run your game. So again, you don't need to run out and get a new PC. It is possible to do this on a partition of your existing dev box. Just understand that you're going to have to boot back and forth, and it'll be pretty disruptive to your dev flow and will make some of the other software we're about to talk about a little harder to use. So I've written the whole process below, and I'll go through the high level here. First up, you'll need to create a boot disk. So what are we installing? We're installing Manjaro, which is a Arch Linux distribution, which is similar to what is on Steam Deck. This version even comes with KDE Plasma, which is the same desktop environment that will ship with Steam Deck. So all in all, this version of Linux is probably the closest thing to what's on the deck to test your game. So go to the website, download the official KDE version, which is free, and you'll get an ISO file. Next, you need to turn that ISO file into a bootable USB. And to do that, you can use Rufus, which is a free application available online. Some people also like using Etcher. Either will work. I used Rufus. It really doesn't matter too much. They're all free. And you'll end up with a boot disk at the end. You'll want to get a USB stick that's at least 4 gigs, and you'll just create a Manjaro boot disk with Rufus. And now that you have your boot disk, you can go down to the next step. When you have your PC that you want to install Linux on, just plug the boot disk in and restart it. And you want to restart it into the boot options. So this will vary by system. On my PC, it was F7, but sometimes you have to hit the delete key. Sometimes you have to hit the F1 key. It really depends. You'll just have to look it up. But once you get to boot options, you can boot from a Manjaro USB drive, and then just follow the instructions. It's a really straightforward install wizard, and you'll even have options to partition your drive if you want to dual boot with Windows or something else. And after that's all done, you'll end up on the KDE desktop. And this is going to look really familiar. It has a start menu, it has a taskbar, it has windowed applications. Nothing is really scary about this. All you'll need to do now is install Steam. And one bonus of Manjaro is that Steam is pre-installed. So you just have to open the start menu, find Steam under Games, run it, let it update, and log in. The last step is to turn on Steam Play. So you'll want to go to Settings and look for the Steam Play category. And under there, you'll be able to turn on Steam Play for all titles. And this will make it so that all of the Windows titles will run through Proton. Make sure Proton Experimental is chosen, and you're done. All you have to do now is download your game, install it, and play it. So now you're testing your game on Linux, which is great. But again, downloading it from the Steam pipe doesn't really give you much room for iteration. You don't want to have to upload a new build to Steam every time you make a change. So we created a way around that. If you were able to find another PC to run Linux on, separate from your dev PC, we've created software that will help you connect and develop from your dev box to your Linux box. And it's called the Steamos Devkit Client and Steamos Devkit Service. Run one on each PC, and you'll be able to upload builds. You can grab logs and traces. You can debug your build. And basically, you can iterate much quicker than trying to go through the Steam pipe. More instructions on this will be provided in the documentation. The last piece of this is performance. So if you really want to find a PC for testing that is similar in specs to a Steam Deck from a performance standpoint, they exist. We went and found one on Amazon, and after a lot of argument, our engineers and folks on the team found that this mini PC is pretty close. It runs an AMD Ryzen 7 3750H. It has Radeon RX Vega 10 graphics, and it has 16 gigs of RAM. So the team agreed that while the GPU is a little weaker and the CPU is a little stronger, it's pretty comparable to the specs of a Steam Deck, especially when running at 1280 by 800. So putting it all together, if you put Linux on this box, and if you hook up a little monitor and plug in a controller, now you have basically a little hacking deck. And this is one way to try and test out your title with everything together: input, display, Proton, and performance. Again, you don't have to do all of this to test. You can do it just as well with the hardware you have available, and you don't have to go out and buy new stuff. Just understand that there may be some differences with performance and display that will differ from Steam Deck. So one last caveat with this Linux box. Steam Deck is actually running a different OS than Manjaro. And with the setup we just shared, things specific to Steam Deck's OS, like GameScope and Gamepad UI, can't actually be tested for yet. We will be following up soon with an image you can use with your test machines that will incorporate these things. And once we have that, you'll have a much more one-to-one test environment as compared to the Steam Deck. So all the things I talked about here are documented on the partner site. And just let us know in the following Q&A or in the developer forums if you have any questions. Thanks.
All right, Lawrence covered a lot of ground during that talk, but we're also seeing some great questions coming in that Lawrence is going to start tackling right now. And Lawrence is here with me live, and we're going to jump right to the questions. The first question that we're seeing is, what's the status on Devkit requests, and how are you selecting who gets a Devkit?
So Devkit requests are still being looked at every day. We do, as I mentioned, have a lot less Devkits available as compared to the size of the Steam developer community. So unfortunately, we just won't be able to provide everyone with one, which is why we made the talk about how to develop without a Devkit. So the good news is we do have another wave of Devkits coming soon, and we will start approving more requests. So if you haven't already made a request for a Devkit, please make sure you do so.
And another question that we were getting is, if I'm a developer that lives outside of the countries that Steam Deck is getting released in, can I still get a Devkit? Am I able to get one?
Yeah, we're sending Devkits around the world. So that's not a restriction.
So next question we're getting is, Devkit EV2 hardware has been reported to have a few issues. Is that being addressed in the retail release of Steam Deck?
Yep, that is the whole point of the EV2 hardware. It's an engineering verification test of where we try building some and we see what issues it has, and then we fix it in the next build. So short answer is yes, those issues have been noted and fixed in the next builds.
That's great. So another question we're seeing is, can we use a VM for development on Steam Deck?
So technically, yeah, but it's not going to be great because you're not going to be able to really test GPU performance. But if you're just looking at UI stuff, you can technically do that, yeah.
So speaking about retail Steam Decks, can you use a retail Steam Deck as a dev kit?
Definitely. There's actually no real difference between the retail dev kits and the dev kits that we're sending out. The dev kits are really just prototype retail units, like I said, from our engineering builds. There's no special hardware. There's no special software built into it. You can use the same tools that we provide for free for development on Steam Deck with a retail Steam Deck.
So for all those developers that didn't get selected to get a dev kit, either in this last batch or in a future batch, are they able to find a way to skip the line to buy a retail unit or get a retail unit?
Yeah, we're looking at that really closely, and right now the plan is we're going to continue working to make dev kits available past and through launch, and we'll have more information about that soon.
Cool. So next question is a little bit more technical. Do you recommend using AMD CPUs when you're creating a test box, or will an Intel CPU work just as well?
Technically, you can use any CPU, but for the closest performance testing experience, you're probably going to want to use AMD.
Mm-hmm. And our last question that we're going to cover today is, if a game is verified on deck, will the visibility be increased on Steam? Will you get more visibility?
Yes, but only on Steam Deck. You'll get a different view of Steam when you're looking at the store from a Steam Deck.
Mm-hmm. So, and just to add to that, the way it works is that the default view of the store on Steam Deck will show games that are verified. But
True.
You can also see games that aren't verified on the Steam Deck. So
you can see everything you want.
Yeah, awesome. Well, thank you so much, Lawrence, for your time today. We are going to move on. Thank you so much for your questions, also, for submitting those. If we don't get to your questions, we will get to those at the end of the day. Our next segment is going to be happening in just 7 minutes, and we're going to be going into a deep dive on Steam hardware. We'll see you in just a few minutes.
Welcome back to Steamworks Virtual Conference Steam Deck. Now, our next talk is focusing on the hardware. And yes, mostly me, tried to come up with a fun deck pun, but below deck is terrible. Every single decision, though, that was made in the hardware design was made with both customers and developers in mind.
That's right. Steam Deck was built from the ground up for an optimal PC handheld gaming experience. And hardware engineer Yazan Al-Dahayat worked on system-wide design for Deck and put together this deep dive on Steam Deck hardware.
Hi everyone, my name is Yazan. I'm a hardware engineer here at Valve, and today I'd like to talk to you about the Steam Deck hardware and how that might relate to your game. At its heart, Steam Deck is a PC, but it's also a purpose-built machine optimized for handheld gaming. Every single block you see on this diagram has been selected and tuned specifically to provide the best possible experience for playing your games on the go. Today, I'd like to walk you through some of the major blocks on this diagram and explain the roles they play in providing the various experiences we want our customers to enjoy. The first and arguably most important block is the APU. Our APU has 4 Zen 2 cores, capable of 8 threads up to 3.5 gigahertz, and our GPU is RDNA 2 based with 8 CUs running at 1.6 gigahertz. Both of these architectures should be very familiar to you. In fact, we think that most games on Steam will not only be compatible with these architectures, a lot of them will be specifically optimized for it right out of the box. The architecture itself should be familiar, but what's truly novel about our processor is that it was designed from the ground up to be optimized for the 4 to 15 watt power envelope available to us in this form factor. AMD is here with us today, and they'll dive a little bit deeper into the details of this APU. But the one major takeaway that I'd like to leave you with today is that the level of performance per watt we were able to achieve with this processor would simply not have been possible using any off-the-shelf processor that exists today. The other major piece to the performance puzzle is memory. Everyone here probably understands how critical memory is to game performance. And for that reason, we selected LP5. Steam Deck is going to be one of the first devices to utilize LP5. And we went with LP5 for 2 major reasons. First one is memory bandwidth. Our APU runs at a 128-bit wide memory bus at 5.5 gigahertz. This combines to a total of 88 gigabytes per second worth of bandwidth, which, if you compare on a per teraflop basis, actually exceeds a lot of dedicated desktop-grade GPUs. The other advantage to LP5 is power efficiency. LP5 offers a lot of great power-saving features that truly manifest themselves in low-power scenarios like 2D games, idle, and sleep. You might have also noticed that we have 16 gigabyte. This is unified between the CPU and the GPU. And the reason why we went with 16 gigabyte is that although most games on Steam today are more than happy with 8 or even 12 gigabyte, we think that that might change in the future. And we really wanted to make sure that Steam Deck is not only compatible with games that exist today, it could also run games that haven't even come out yet. Having a performant APU and memory is not enough. We also need to make sure that the power and thermal policy for this product makes sense. Our primary objective was to provide consistent performance for extended periods of time. Unlike a lot of laptops and phones, we do not rely on things like turbo boost, peak clocks, or any kind of bursty performance, and instead use only clocks that we think we can sustain indefinitely. What that translates to is that the performance your game gets in the first 10 seconds is likely to be the same performance you get 2 hours from now, or maybe even indefinitely if you're plugged into the wall. And that's not the only thing we focused on. We also wanted to provide consistent performance across a wide range of scenarios. You should get the same performance whether you are plugged in, on battery, docked, charging, not charging, downloading games, or even in some elevated ambient temperatures. With that said, there's definitely a limit. If you're in Florida in July, you might run out of thermal headroom. And when that happens, we'll do our best to maintain the GPU performance by throttling things like charge rates, download speeds, even SSD bandwidth, to try to maintain the GPU clock running as high as possible for as long as possible. We can't talk about performance without also talking about battery life. And we spent a lot of effort making sure that every single subsystem in Steam Deck is running at its most efficient point. But really, all of that should be very transparent to you. The one thing that you should note is that we did not place any artificial limits on how much power the APU can consume. For that reason, we think that most games would benefit from having some kind of an FPS limit, whether that be 60 FPS to match the display, or 30 FPS for some of the more GPU-bound games. If your game already has an FPS limiter, then that's great. If not, we're working on a global FPS limiter that will allow the user to pick the optimal balance between performance and battery life that suits their needs. Another aspect to battery life that we really focused on is power consumption during sleep. We think that a lot of our customers are really going to enjoy being able to suspend their device, walk away for hours, maybe even days, and come back and jump right where they left off in their game. We really encourage you to take advantage of that by making sure that your game is robust to being suspended for long periods of time. Now, despite our best efforts, Steam Deck does have to be charged every once in a while. And for that reason, we have a Type-C port capable of 45 watts. That should be enough power to both run the device at max load and simultaneously charge at a full rate. The Type-C port could also support external peripherals up to 7.5 watts, which is enough for things like webcams, wired controllers, or even storage devices. You could also use the Type-C port for docking, and in that mode, we can support up to 2 4K displays at 60 Hz. And if you opt for half the display bandwidth, you will get USB 3 Gen 2 instead. At this point in time, I'd like to shift gears a little bit away from power and performance to talk about other subsystems like audio. For audio, Steam Deck users will have many options. They can either use the built-in speakers, headphone jack, built-in microphones, Bluetooth audio, or even audio over HDMI or DisplayPort if they're docked. Every single one of those options has a slightly different audio processing pipeline. For the built-in speakers, we have a dedicated amp and DSP that monitors the speakers in real time and adjusts the audio stream accordingly. Every single Steam Deck has been calibrated at the factory to provide the best possible performance, and we're really proud of the level of fidelity we were able to achieve with this setup. On the other hand, the headphone jack and the built-in microphones, although do have a dedicated codec, we opted to do more software-based processing than hardware. We rely on Steam itself to do some of the most advanced techniques like echo cancellation, and we think this approach provides better flexibility and more compatibility with various different pieces of software and hardware. I also mentioned Bluetooth audio. Steam Deck supports Bluetooth 5.0. And the great thing about Bluetooth 5.0 is that it can support Bluetooth low energy and Bluetooth enhanced data rate devices simultaneously. It also has double the bandwidth of Bluetooth 4. What that means is that you should be able to use your Bluetooth headphones and several Bluetooth controllers at the same time. In addition to Bluetooth, Steam Deck also supports Wi-Fi AC, which provides up to 866 megabits per second worth of bandwidth. At that level, we think that Wi-Fi bandwidth is unlikely to be the bottleneck for your game downloads. Wi-Fi bandwidth is only half the story. We also focused on Wi-Fi reliability and Wi-Fi robustness, even in congested RF environments. We wanted to provide a first-class Steam remote play experience on Steam Deck, and we think that for our customers who have a powerful PC and good Wi-Fi at home, they are really going to enjoy being able to play their games at a substantially reduced power consumption compared to running the game natively on the device. Finally, the last block I'm talking about today is storage. Just like with audio, Steam Deck customers will have several options. They can even run their games on the built-in SSD or opt for removable libraries using an SD card reader or USB 3-based storage devices. If you compare these options on paper, they have very different levels of performance when it comes to read and write speeds. But as you can see on this chart, if you actually compare them in terms of user experience, you'll find that that difference shrinks quite a bit. When it comes to load times, the SD card reader loads the game about 18% slower compared to the NVMe 512GB SSD. Similarly, when it comes to boot times, the 64GB eMMC boots 25% slower compared to the built-in NVMe SSD. Now, I do want to emphasize that this represents a single data point and that different games might scale differently. But in general, we think this data is quite representative of most games. Now, the difference between the different storage options is definitely meaningful and is consistent. However, we think at this level of performance, all three of them offer a great experience, and our customers will be very happy with regardless of which option they choose. This covers the major blocks in the Steam Deck hardware. I hope you found this information helpful, and I look forward to taking your questions in the Q&A session. Thank you.
look forward no more, Yazan, because it's here. Yazan's here to answer some of your hardware-focused questions when it comes to Steam Deck. We have a lot that have been coming in, so thank you for coming back.
Thank you, and hello, everyone.
So the very first one that came in has to do with multi-threading. Does Steam Deck support multi-threading?
Yes, Steamdex CPU can support up to 8 threads.
Okay. And are there any plans to add 5G or LTE?
At this point in time, unfortunately, we don't plan that or haven't really considered it. However, you can always tether to your phone if you're out of Wi-Fi coverage.
Okay, got a lot of questions on maximizing battery life. Do we have any specific recommendations?
So I think I mentioned in my call that really the most effective way for you to maximize battery life is to rely on FPS limiting. We think that that's really the best way to kind of achieve the right balance between performance and battery life. Now, obviously, you can experiment however you'd like, and we have a lot of hooks for it, but FPS is really where you should start.
Okay. What about when it comes to supporting the Deck Suspend and Resume in-game? Do they need anything specific that they have to do?
At this point in time, we actually don't think so. From experience, most games seems to perform just fine coming out of Suspend. Having said that, we definitely encourage you to test it and make sure your game does support it. And also, we have some cloud APIs that we should check out to make sure that your save files do get synced appropriately when somebody suspends their game. But overall, from experience and in theory, all games should just run out of the box well.
Okay, so what about when it comes to spare parts? So some folks are asking, will there be a spare parts store available? And if so, is there a timeline for it?
We are working on it. We don't really have any details to share right now, but we are definitely committed to providing as many spare parts after we ship as possible.
Okay. Are we planning any hardware improvements by any chance?
Really, we're focusing right now on making sure the current Steam Deck Gen ships and is the optimal experience that it can be. So we don't have anything to share right now, but definitely looking at a multi-generational product here. So
I feel like I'm like peppering with questions.
That's
like,
okay.
tell me the answer. Okay. Next one is about VRAM. How much VRAM is on Steam Deck?
So obviously, it's 16 gigabyte of unified memory. We have 1 gigabyte that's dedicated for the GPU, but really the GPU can also access up to 8 gigabyte depending on what's happening. So really, you can really expect to have at least or up to 8 gigabytes for any game or the GPU itself.
Okay, and this is a great question that came in because I recognize that we dealt with it a little bit when we had a few press reviews come out over the summer. So we definitely want to talk about it again, which is, will the performance of Steam Deck be any different depending on if it's plugged in or if it's running on battery?
So as I mentioned in my talk, we really focus on providing you the full performance available for our APU, both on battery and when you're plugged in or docked. So our expectation is that the performance is going to be about the same across the board, whether you're on docked, on battery, or even plugged in.
Okay. What about Ethernet speed on the dock?
Currently, the dock supports 1 gigabit Ethernet, and so you should be able to use that if you have gigabit Ethernet at home.
Okay. I think that's it. Do we have any more? I'm going to ask our peanut gallery in the back who's been collecting questions. I got a very solemn... No, we're good. All right, great questions. Cool. And if anybody else had questions that came up during Yazan's talk or during our Q&A that didn't get answered, we're going to try to answer a little bit more at the very end.
Thank you.
Maybe you can come back and help us with that.
I will be around.
Okay, thank you.
Thank you, everybody.
Yazan.
Bye.
All right, so coming up next, we have 2 of the folks from the Steam team who are going to join us to talk about Steam on Deck, and that segment is starting in just a few minutes, so feel free to take a stretch, grab some coffee, and we will see you in just a bit.
We are back. Now, today's Steamworks Virtual Conference is all about Steam Deck, and we're covering everything from hardware to software.
And when it comes to Steam features on Deck, they just work. Seriously. Software engineer Tom Bowie and product designer Tucker Spofford outline how, and they're also taking us through some of the newer Steam features made for Deck and the desktop client.
Hi everyone, I'm Tom, and I'm a programmer on the Steam Deck.
And I'm Tucker, a designer here at Valve.
And today, we're going to talk to you about the Steam experience on the Steam Deck. If you can take away one thing from this session, it is this. Steam features will just work on the Deck. Because at the end of the day, the Steam Deck is just a PC, but in a handheld form. Now, we realize that's a bold statement, but we're working hard to make sure all the features customers love are accessible on the Deck. Here are just a few examples. If your games utilize Steam Cloud, whether through AutoCloud or the iSteam Remote Storage API, players will be able to play a game on their PC, take a break, and later grab their Steam Deck and pick up right where they left off. If customers have mods they have subscribed to in the Steam Workshop, they can use them right on the Deck. This is especially important if their save games depend on those mods being on disk. And of course, customers can unlock client-validated achievements, even if they are not connected to the internet. The Steam client will sync right back up with our servers once the user goes online again. Steam community features will also be just a few button presses away. We plan to make game hubs, forums, player profiles, and the activity feed accessible in some form. We're also making larger changes to the friends list and chat to make them easier to use on the Deck. To help with the lack of a physical keyboard, we're introducing a new virtual keyboard with IME support. And of course, customers can quickly and easily use voice chat to communicate with their friends.
Something we know that it's important to all developers is how their game is represented on the Steam Store. The Steam Store has been optimized for the Deck so that it's accessible with the gamepad, but will still have all the same powerful features that customers have come to expect. The first page of the store is filtered to games that are a great experience when you're playing on Deck, something we're calling Steam Deck Verified, and some of the other talks have touched on. But users can easily browse and explore the rest of the catalog at any time. Wish lists, search, daily deals, publisher pages, users will be able to use this powerful tools that they're used to on the desktop right from the Steam Deck device. All the new features from our recent library update on desktop have been refactored for Deck to make it accessible and easy to use on the go. Our goal is to help you as a developer connect with players no matter what device they're using Steam on. We're also introducing some new features to help things work even better on Deck. Something new for the Deck is the home screen, which brings together content in one place across your library, friends, and the Steam Store. Players can even find your game in the store directly by searching for it with the new universal search. Search combines results from your users, library, friends, and the store. So even if a user doesn't own your game, they can find it just by going to the top of the screen and using the universal search. As you can see, we're also putting a lot of work into improving the keyboard, something that Tom talked about. We're building in support for IME, multiple languages, layouts, and even emojis. And that work is going to be accessible for you to use in your game through our new keyboard SDK. Notifications are something that Steam's had for a while, but they're now unified in one place that's accessible with a dedicated hardware button on the Steam Deck. So you'll be able to see what's happening from anywhere in the UI. The new Steam experience will also be easier for us to maintain and keep feature parity with the desktop client. In the past, Valve hasn't always been able to keep big picture features up to date with everything that users see in the Steam desktop client because the UI is two completely separate code bases. As part of the work we're doing, we're also optimizing for when you connect to a TV so that these new features will roll out as a big picture and streaming UI replacement soon. By bringing everything together, we can add new features to Steam and you'll see them almost immediately on Deck. One example that I know I'm excited about is the updated Steam Input Configurator. Our updated design system includes features that are designed to be accessible whether using a keyboard and mouse, a controller, or the touchscreen. The new UI is easier for both customers and developers to use, and we're completely rethinking how we present information so that it'll look a lot more like what your customers are used to seeing in a game. You can see that the experience is going to be consistent whether you're on the desktop client or on the Steam Deck. And there's a fresh new set of controller glyphs that cover the most popular controllers on Steam. That includes glyphs for the Steam Deck. Those glyphs have been designed to make it easier for you to change the appearance in the game so you can really make the content feel seamless. And if you hook up our API, you'll know that your customers will always get a great experience no matter what they're playing with. So Tom is going to walk through how you can implement some of those features and actually make them work with the Steam Deck.
While we've taken care of most things, there are a few ways you can make your games be a better experience for your players on the Steam Deck. I'm going to quickly go over the APIs here, but we'll provide links to the documentation on the partner site. So there may be situations where you want to know that your game is running on the deck. Most of the time, you'll probably want to check the capabilities of the computer yourself. But as a shortcut, you can use the "Is Steam running on Steam Deck" function. In this example, we're suggesting performance presets to the user. For different UI layouts, we'd actually suggest you ignore this function and instead make decisions based on the output resolution. This is because a Steam Deck can be docked, or it could be streaming a game to another device. There's also some new suspend resume functionality that you may want to take advantage of. Normally, Steam Cloud files are synced when the user quits the game. But you can now opt into a feature where we'll sync cloud files for you while your game is running and the user suspends or resumes the Steam Deck. First, you'll need to tell us that your game supports this feature by going to the partner site and checking a checkbox. Then, when the Steam Deck gets suspended, we'll upload any files that have changed since the beginning of the game session. Note that you should wrap your code where you write files to disk with begin and end file write batch, as shown in this example here. This should be done regardless of whether you're leveraging AutoCloud or using the iSteam Remote Storage API to write to the Steam Cloud directly. Steam will use this information to help ensure that your game is done writing the most recent state to disk before suspending the process and initiating Cloud Sync. Otherwise, we could upload files in an inconsistent or even corrupt state. Now, when the user wakes the device up, before unsuspending the game, we'll download any changes from the cloud. Once that is done, we'll resume the game process and post an app resuming from suspend callback. In this example, we're automatically pausing the game and showing a resume screen. If there were any changes downloaded, we'll also send the remote storage local file change callback. You can then use the get local file change functions to iterate over any Steam Cloud files that have changed while the game was suspended. In this example, if we found a newer save game file, we'll then upload the list of save games in memory. But if any save games were deleted, we'll return the user to the home screen. Now, if players ever have to interact with the keyboard or enter text in your game, there are a couple APIs you'll want to be aware of. Game launchers don't work particularly well with gamepad controls, but if your game requires one, you can put the Steam Deck UI into a special mode by calling set game launcher mode. This will make the device emulate a keyboard and mouse so the user can proceed without getting stuck or having to use the touchscreen. You can also use this mode if you have an embedded web browser in your game and you expect the user to use a keyboard and mouse. If you need the user to enter any text in your game, you can activate the Steam Deck floating keyboard by calling show floating gamepad text input with the screen coordinates and dimensions of your input control. This will position the keyboard so that it does not occlude the area the text would show up. When the user is done interacting with the keyboard, we'll send the appropriate callback so your game can continue, at which point you can do things like focus a button in your UI and ask Steam for what the text the user entered is. Now, moving on from APIs, let's talk about content. One concern we've heard from both developers and customers is that PC games can be quite hefty. How will that work on the deck? Well, if your game depots are full of high-resolution textures, audio, or movies, you may want to consider configuring depots with lower resolution versions specific to the Steam Deck. You'd upload that content through SteamPipe just like you would for any other depot, but then you'd mark it as Steam Deck only on the partner side. Doing this will help customers download your games faster, take up less space on their device, and have better in-game performance.
We'll provide links to the documentation where you can learn more about the APIs and what you can do to help make your games the best they can be for your players on Steam Deck. Hopefully you guys have found this helpful, and we're looking forward to your questions in the Q&A.
All right, we're back, and I'm here with Tom and Tucker, and we're going to be answering your questions right now, and I guess we'll just dive right into those, right? So the first question is for you, Tucker, and that is this. So when will this, will this UI that's used on the deck end up replacing Big Picture? And if it does, when will that happen?
So the plan right now is that it will replace the Big Picture UI, so that's something that we're planning on. Our focus right now is really on getting the Steam Deck shipped, so we want to make sure that we're really optimizing for that platform first, but pretty soon that will be the Big Picture replacement.
Awesome. So next question, Tom, it's for you. Does Deck only support full screen mode, or does it support anything else?
Well, right now on the device, we'll make sure the games are in full screen mode. But of course, if you drop the desktop, it'll be just like a PC, so things can run windowed in that case.
Right. So do you plan to release SteamOS as a standalone general purpose OS?
Yeah, we definitely plan on releasing SteamOS as a separate operating system. We don't have exact timing on that. Again, it's really kind of the same answer as Big Picture. We're really focused on making sure that Steam Deck is a great experience, and then, but we hope to release it to other platforms soon.
Next question is, again, for you, Tucker. Does Deck support installing software from outside of Steam and use it with Proton?
Yeah, so you can totally install any game like you would on the Steam desktop. You install the application and then add it to Steam, and it'll show up, yeah, just like it would on a regular PC.
Cool. So this is the last question that we have. Just a couple questions here, and this one's for you, Tom. Will Steamdex support VR? Is that in the future?
Technically, it's possible. We've seen people jury rig it, but we definitely didn't design and build the device for VR. So.
Yeah. All right. Well, thanks so much for your time. And if you have other questions, keep posting them, and we will get to them at the end. And we have next up a deep dive into Proton support. That's coming in just about 30 minutes.
Hello, good to see you again. In case some of you are stumbling across the event now and missed the welcome, I'm Casey.
And I'm Eric, and we work on the Steam team here at Valve, among doing a bunch of other stuff. So don't forget that we have live chat below this video where you can interact with fellow developers, and the Q&A function is working throughout the entire event, so you can type in your questions anytime you want. We're doing our best to collect the ones that aren't necessarily specific to the talks, and then we'll circle back at the end of the event to answer as many as we can.
In the meantime, back into the conference we go with software designer Pierre-Loup Griffet and a closer look at Proton support.
Hello, I'm Pierre-Loup, and for this section, I'll share some details on Proton, which is used to make Steam Deck compatible with Windows games. As a little bit of background, Proton is a compatibility layer distributed through Steam. It's downloaded and set up automatically when running any game that needs it. It's made up of a collection of different open source projects, including a heavily modified distribution of Wine. It is not an emulator, meaning that your game's executable code runs as is without any modifications. However, when the app makes an API call that would normally go to an external Windows OS library, that call goes into Proton code instead. The call is then implemented using Linux APIs and open standards such as Vulcan. After a few years of development, an initial version of Proton was released to Linux users for testing in 2018. Since then, with their helpful feedback, we have been continually developing and releasing new features to improve game compatibility and performance. The effort is directly supported by Valve through our partners, our Codeweavers, as well as our own open source graphics group. The project is now at a stage where a ton of games work really well. That means they show no functional difference compared to when running on Windows. As most common APIs are already implemented and well tested by a wide variety of existing games, it's pretty common for a new title to work perfectly out of the box without any work needed on the developer's part. That being said, the overall surface area is quite big, and there's no shortage of gaps left to cover. Running into Proton coverage issues could mean a delay before a newly released title can be enjoyed on deck. Here's some general tips on technology choices that might help avoid those gaps. We understand those are only likely to be useful for a project in early stages of planning. A good rule of thumb is that there is more room for error in Proton when the game uses massive external libraries, as opposed to code that it includes in its own build. For example, a built-in browser engine like the Chromium embedded framework is less likely to have issues than MS-HTML. In general, we don't recommend launcher windows, but if you have one, a library such as Qt is trivial to support, unlike something like .NET WPF. For video playback, libvpx or Bink are better alternatives than Media Foundation. Complex or invasive anti-temper or anti-cheat frameworks can be hard, or even impossible to support properly without direct involvement from their provider. Another thing that can be a huge help is for our team to be able to test and debug the game pre-release. As part of the Deck Verified program, we'll be offering tools to submit your build for pre-release testing. Such testing often allows us to uncover low-hanging fruit in time for release. As discussed today, you can also do your own testing and remote debug your application running inside the Proton environment. On the graphics side, the latest APIs like DX11 and 12 are supported through purpose-built drivers based on Vulcan. If there is a choice between the two APIs, things are now at a point where DX12 through Proton tends to be a better experience in cases where it's also a better experience on Windows. Unlike DX12, DX11 translation is heavily reliant on dynamic shader recompilation, which can induce stutter. To address this, we have developed a robust shader precaching system as part of Steam. It lets all the needed permutations be processed before the game starts. This system is currently being improved for the deck, so that the processing is done on our servers ahead of time, as opposed to the user's machine. For Proton as a whole, graphics API translation also tends to be the main source of significant CPU overhead. On deck, this manifests as increased power usage, which can slightly reduce battery life, or reduce GPU-bound performance. That means that the biggest opportunity to improve Proton performance is to target Vulcan directly. It's no small task, and as such, we only recommend it in cases where it would make sense to also focus on Vulcan as your primary API for Windows. If you are using an existing engine that supports Vulcan, we recommend to enable it for your Windows build and report any performance or functional difference to your engine vendor. If your game doesn't work well in Proton, it likely means there's a bug or coverage issue on our end. We're always working to resolve those in the background, so please do report it on the developer forums. We're also working on tools to let you flag compatibility issues more directly through the partner site. If your game is already out, the Proton public bug tracker can also be a good source of information about the expected state of things, and might contain useful tips or workarounds for you to reference. I hope that helps clarify how Proton functions, and how you can rely on it to target Steam Deck without a Linux version of your game. We're not talking about native Linux support today, but we'll definitely be talking more about that in the future. For now, if you have questions about Proton, let us know in the upcoming Q&A.
All right, Pierre-Loup, thank you. He's here to answer all of your Proton-related questions and more, and we did get a bunch of really good ones in chat, so are you ready?
Yeah, definitely.
Is that your ready face?
I'm really ready.
I love it. Okay, so the very first one has to do with Proton testing, and people are wondering if it's going to be part of the game submission process moving forward.
Yes, actually, we're going to wrap that up into the deck-verified testing that happens before game release, which will give us pretty good opportunity to uncover some of these Proton issues before the game makes its way to users.
Okay, makes sense. The next one is about apps. Will apps that aren't on Steam work with Proton and be usable on the deck?
Yeah, definitely. Proton works great with apps that are outside of Steam as well. And on the deck, we'll actually be improving the UI experience to add non-Steam games to the main UI.
Okay. Next up is what kernel version will be used on SteamOS?
Well, there's not a straightforward answer to that because we're always looking to update to the latest kernel version. Right now, we're using 5.13. We're working on an update to 5.15, and we're always going to be rolling out whatever's the latest.
Okay. Will SteamOS have a read-only immutable OS file system?
Yes. So by default, the OS updates will be distributed as a whole OS image. But you can enter a developer mode, which will let you modify the file system and install packages like a normal distribution.
A couple of developers had some questions about the system being Wayland-based, wondering if there's any known performance hit to existing games or any missing functionality to be aware of.
Oh, that's a good question. There's no known functional differences or performance problems, but if people hit anything, we're always eager to look into those.
Okay, now this is something that we've heard from a lot of customers as well, and we know developers are really interested in hearing about this, is whether Steam is working closely with leading game engine developers Epic Games and Unity about Steam Deck?
Definitely, yeah. We're always working with both Unity and Epic on making sure Unreal and Unity Engine have the integration that was going to make the dev experience working on these engines to target their games on deck as smooth as possible. And I think there's always going to be improvements rolling into the engines to integrate things with our dev tools and make it a great target for deck. But already we're seeing a pretty good experience from the get-go right now.
Awesome. Next question is, can we use more than 1 GB of GPU memory for textures, vertex, and other buffers, or is that a hard limit?
No, actually more than 1 GB is definitely available to use with the GPU. Up to 8 GB can be shared right now, and it's a limit we can actually change on a game-by-game basis.
Okay, lots of questions coming in about Proton and native Linux support. So would you prefer a game to use Proton or to have native Linux support? What's the stance on that?
Well, we have no strong preference. Really, as we discussed, it comes down to whatever's the best experience. So if it's easier for the developer to get to a point where the best experience is achieved through Proton, we think that's great. But if they have the know-how or the resources to work on a native Linux build, that's a mouthful, yes. that has great experience and has all the functionality, and they're able to maintain it, we think that's even better.
Okay, and when it comes to Proton issues, is there a standardized way to report those?
Yeah, so the canonical spot where those are reported is our GitHub, where a lot of the game issues are being discussed and reported. But you can also get in touch directly with us, through the Steamworks forums, for example.
Okay, well, everybody had such great questions, so thank you so much, and thank you for taking the time.
Thanks a lot.
We appreciate it, and I know a lot of you are still asking some questions that may not be specific to Proton, and that's okay. We're saving up as many of those as we can, and we're going to make sure that we answer some of those at the very end of this event. We are now just about 2 minutes away from our next segment, which is our APU Deep Dive with AMD, and we're so excited to have them join us. They'll be back in just a little bit, 2 minutes.
Hey everybody, welcome back to Steamworks Virtual Conference Steam Deck. Well, we've been hearing from a lot of members of the team behind Steam Deck on the Valve side, but we've also worked with the folks at AMD throughout the development process and are happy to have them joining us today.
Sebastian Nussbaum is AMD's Corporate Vice President of Products and Technologies, and he's here to go over the technology that powers Steam Deck's custom APU. He'll also be joined by his colleague Alex Duiker to take your questions immediately following.
Hello everyone. Today it is my pleasure to introduce the collaboration between AMD and Valve towards Steam Deck. My name is Sebastian Nussbaum. I'm Corporate Vice President of Products and Technologies in the Semi-Custom Business Unit at AMD. When Valve and AMD started discussing the silicon solution to use in Steam Deck, we focused on the performance versus power trade-off to enable an excellent gaming experience in a handheld form factor. The APU was designed from the ground up, optimized for consistent performance for extended period of time, running a variety of gaming workloads in the 4 to 15 watt range, which is a very different considerations and trade-offs in architecture, manufacturing process, and configuration compared to a typical notebook APU, which are usually more optimized for short durations boost and can be scaled up to about 45 watt operations. Even the package where the silicon is included is optimized to reduce the size by over 2/3 compared to a typical notebook PC package, and to optimize the thermal solution and the size of the system. Given the right feature and configuration was critical to the solution, this is where we spent the most time. The AMD custom APU in Steam Deck is also the first mobile APU to leverage the same RDNA2 graphics found in our latest high-end PC and console graphics. The same RDNA2 graphics feature set that is both DirectX 12 Ultimate capable, plus supporting the latest Vulcan feature set, including variable rate shading, ray tracing, and mesh shaders. For the memory subsystem, the AMD custom APU in Steam Deck is the first AMD processor to use LPDDR5 memory technology, providing both much higher memory bandwidth than DDR4 or LPDDR4, and also improves performance per watt further to enhance battery life. Throughout the development of Steam Deck, AMD and Valve worked together closely to tune hardware, firmware, and software. This collaboration helped to accelerate both game loading times and also boot times. A lot of attention was placed on finding the right balance to get power efficiency with smooth frame rates. Together, we looked at both the latest demanding games and also less graphics intensive games. Our combined focus on automated power management gives you the best performance when the game needs it, but minimizes power when it doesn't. For example, if your game is frame capped at 60 frames per second, and the frame renders in 8 milliseconds, then the AMD APU will go into a very low power state for the rest of the 16.7 milliseconds. Going beyond the automated power management, extra knobs are available, allowing developers to manually tune and experiment trade-offs between gaming experience and battery life. Overall, the results exceeded my very high expectations for what we could accomplish by having the Valve and AMD teams work closely together to optimize the handheld PC gaming experience. An aspect of Steam Deck that I have been impressed to see is how developers can leverage not just their Linux applications, but also Windows applications as is, or with minimal changes. This includes supporting all 3 major APIs on Windows across DirectX, Vulcan, and OpenGL through the Proton translation layer. Of course, games on Windows utilizing the Vulcan API will need fewer software layers through Proton and will make more efficient use of the hardware. With Steam Deck and SteamOS, developers have full access to the open source Mesa graphics drivers such as Radeon SI and Radley. AMD has been collaborating with Valve now for many years to improve Linux gaming. Together, we have made significant contribution to the open source Linux driver stack, and we are seeing the fruit of those efforts realized in Steam Deck. Beyond the drivers, there are also multiple software tools available to developers for driver and workload debug and analysis. Those tools include Renderdoc, Radeon Graphics Profiler, GPU Trace Visualizer, and user mode register debugger. These tools and the open source driver stack enable game development to be much more efficient. developers can debug their crashes and profile their workloads without needing to rely on direct help from Valve or AMD. That being said, both Valve and AMD are actively participating in the open source community, and we are ready to be reachable whenever help is needed. Renderdoc is an API-level tool for debugging applications that many of you are likely already very familiar with. With Renderdoc, you can capture a frame of an application using a supporting API, including OpenGL, Vulcan, and DirectX, and then use the tool to analyze or edit the state of the API to achieve your desired output. Let me talk to you a little bit about Radeon Gpu Profiler, or RGP. RGP is a tool that was originally developed by AMD. This tool is a GUI-based application available in both Linux and Windows that is used for application profiling and tuning. RGP allows PC game developers to have more in-depth access to the GPU and to easily analyze graphics, async compute usage, event timing, pipeline stalls, barriers, bottlenecks, and other performance inefficiencies. RGP was developed based on the shader Q thread trace hardware features, which were added for the consoles and productized on PC graphics as well. Shader Q thread trace is a special profiling mode which dumps performance states from the GPU pipeline in hardware and then provides visualization and other information. You can see how much time you've spent in various shader stages on the hardware, and within shaders, you gain more insight into the details of instruction latencies, for example. To generate the traces for RADV and Radeon SI, you will need to set environment variables when you run the application. You also have to tell the kernel driver to enter a polling mode that uses fixed graphics clocks and disables power management to ensure that you get consistent, properly scaled results. Here's an example view of the RGP tool. You can get a bird's eye view of how your command buffers got submitted to each GPU queue and understand how your graphics, async compute, and copy workloads interact and synchronize. With RGP tool, you can understand how your wavefronts were pushed to the GPU. You can also correlate between wavefronts and the GPU events which launched them, and provide insight into how your frame utilizes the various GPU memory caches. The data displayed in this view is highly filterable, groupable, and includes a side panel with added details about user selections. RGP tool can also help you quickly and easily find hotspots in your shaders using the instruction timing view. Each instruction in your RDNA ISA has a bar showing its average latency, allowing you to find the right things to optimize. With RGP tool, you can find out which barriers flushed caches, caused a synchronization point, or even ran their own internal shaders. Burst those pipeline bubbles and claim back your performance. Let me talk a little bit about GPU Trace Visualizer, or GPU Viz. It is a Linux GPU profiler similar to GPU View on Windows. It's designed to work with trace command captures and help track down Linux GPU and application performance issues. This is a tool useful to visualize trace events generated by the kernel driver, and also for analyzing utilization problems to determine if an application is GPU bound or CPU bound. GPU Viz lets you see when the work is scheduled on the GPU and when it completes. You can also view things like VBlank events to help understand timing and related problems to your timing. Additionally, you can see when the application are calling driver I/O control codes or I/O controls, or maybe just for checking the status of a buffer. For an example, let's say while checking your application that you observe artifacts, GPU Viz may see that you have work scheduled on the GPU happening in parallel on two separate engines rather than sequentially. And that sequentiality was critical to your application. You discover the work between those two engines was not synchronized, and you're adding missing fences or semaphores to address the issue. Here's an example of GPU Viz. You can see that the work on graphics and compute are actually running in parallel here. However, the jobs were supposed to run in sequence due to dependency. The compute jobs needed to wait for the result of the graphics, and the application needed to wait for that compute job to finish. After a bug being fixed in the application, you can see the jobs are running sequentially. Here's another example. We can use GPU Viz to analyze load balancing on CPU and GPU. This example shows a GPU that is fully loaded. And in this one instance, we're showing GPU Viz enables you to see that there's probably performance left on the table because there's a gap in the GPU workload. I want to talk for a little bit about UMR. The last tool that we'll talk about today, User Mode Register Debugger for AMD GPUs. It's a command line tool for debugging the GPU driver. UMR communicates directly with the GPU kernel driver to allow you to read registers, check power state information, and telemetry data like temperature and power. And also allows you to check the state maintained by the driver, such as GPU virtual memory page tables. It is useful for debugging kernel and user mode drivers if you are seeing strange behaviors or something like a GPU page fault. I would like to close today. AMD is very excited to be a partner of Valve and Steamdeck. Gamers will be able to play their PC game library on the go and have access to a huge catalog of amazing games, including the latest AAA titles. AMD is committed to delivering the best experiences to gamers across the world on PC, console, and portable devices. Thank you.
Great talk, Sebastian. Thanks so much for taking the time to be with us live today. And we also want to welcome your colleague, Alex Duiker. So we've got just a couple of questions to get into today, but let's just dive right into them. So Sebastian and Alex, thanks so much again for joining us. The first question is, will DEC support the new Vulcan dynamic rendering feature?
Yeah, I can take that if you want, Eric. Thank you. The short answer is yes. You know, the work is already in progress to support it, and the hardware supports it. So it's a question of driver support for which the work is underway to get that started.
That's great. So the next question that we have from the audience is, will AMD FSR be incorporated into Steam Deck?
Very good question. So FSR is, of course, today available for some applications. Already supports it. So the games that already include FSR will work as is. But also, FSR support will be included as part of an OS future release. Therefore, you could potentially use it for games that don't natively support it.
So we're seeing some interest in another technical question for you, and that is, does Steam Deck's APU utilize Smart Shift?
Yes. So a short answer to this question, as a system level, we spent a significant amount of time optimizing to make sure that the firmware that's running within the processor at the heart of Steam Deck is constantly measuring what's the right ratio of performance versus power and what is the right clock frequency to apply to the CPU versus the GPU. And so in that optimization that goes on while the game is running, you basically constantly deliver to a best experience as either a battery life experience or performance need when the performance needs it for the game.
All right, so just one more question for you today, and that is, will AMD GPU Profiler be able to run on Linux natively?
Alex, would you like to take this question?
Sorry, it cut out there for a second.
Sure.
What on Linux?
The question is, will the AMD GPU Profiler be released to work on Linux natively?
Yes, it works on Linux natively today. The graphical user interface and all. The support for taking the traces natively within it is something that we're looking into. So you'll have to take them, as Sebastian said earlier, you'll have to take the traces from within your application. But then you can view them and use all the tools within RGP natively today.
All right, thank you, Alex. Sebastian, thank you so much for being with us today. We have one more segment left before we open up to your questions for one final time. So take a really quick coffee break, and we'll see you back here in just 2 minutes for a look at Steam Input.
Thank you, Eric.
Hey everybody, welcome back. This is the final official talk of today's Steamworks Virtual Conference that's all about Steam Deck.
But wait, there is more. After this segment and the Q&A that follows it, we're going to be coming back with a very final wrap-up where we tackle some of the extra Steam Deck questions that have been coming in throughout the day. But first, let's get into that final talk.
Scott Dalton is a designer that has packed a lot of great info into his next segment that is all about Steam input. So stick around for a live Q&A with him immediately following his segment.
Hi, I'm Scott, and I'd like to walk you through some information about input on the deck. The Steam Deck controls are a superset of X input, so if your game has been designed around X input and you're happy with it, there may be nothing else for you to do. However, the Steam Deck offers some powerful new controls you may want to take advantage of via Steam input. Steam input is composed of two parts, a robust remapping engine for translating low-level controller input into game-ready output, and a hardware-abstracted action-based API. Both are exposed as user-customizable configurations. So whether you've already got great controller support and you want to take it a bit further on the deck, or it's your first foray into adapting your game for controllers, we hope Steam Input has something for you. Steam Input has support not only for the Steam Deck and Steam controllers, but also Xbox, PlayStation, and Nintendo Switch controllers, as well as direct input. The PC has always been a platform that's about user choice, and we know that users like a wide variety of controllers to play their games. Now, X Input provides an excellent stable base for gamepad support on PC, but an unfortunate downside is that many games don't recognize the variety of hardware available. This means that even with outside translation into X Input, on-screen button icons don't match, and their controls are limited to a subset of what that controller may offer. This is where Steam Input comes in. The Steam Input API offers an action-based API that is abstracted away from the hardware. So for example, instead of looking for an A button to determine when to jump, your game is looking for a jump action. You can query the API for hardware-specific origins of an action in order to display the correct button icons, and also get the appropriate icon artwork, if necessary, directly from Steam. This abstraction allows for future-proofing, which means that new hardware and new icon artwork can be supported without shipping an update to your game. But what's more, you can map these actions to gyros, trackpads, and additional buttons that simply don't exist in X Input, so they can be first-class citizens of your game. We recommend investigating Steam Input's action-based API if you're looking to add controller support or want to design your controller interface around fully embracing novel input methods. This is particularly true if your game is in a genre that relies on a cursor or just isn't well suited to standard gamepads. But what if you already have excellent controller support? One of the benefits of Steam Input is that we provide ways for you to make use of some of these features without implementing an entirely new API. You can query for the user's controller type, as well as translate your internal button layouts to the controller they are using. And again, look up and get on-screen icon artwork based on this data. The Remapping Engine allows you to take advantage of inputs like gyros and trackpads through your existing systems, particularly if you support simultaneous gamepad and mouse. This is just a configuration change, so even games that are no longer actively in development can be supported this way. It's worth noting that allowing your game to accept mouse movement simultaneously to gamepad is key here, as it allows for trackpad and gyro-style inputs to control a camera or a cursor. Doing so allows for players to reach near mouse levels of speed and accuracy. For an example of how easy this can be, let's take a look at an existing X Input title, Ghost Runner. So I'm going to quickly jump into the configuration for this game, and I'll set the right trackpad to be a mouse. I'll set the gyro to be a mouse as well, because as we mentioned earlier, this sort of gyro control offers fast and precise one-to-one input. This game allows for simultaneous gamepad and mouse, so that's all we have to do. Note that if your game changes glyphs based on mouse input, you'll want to avoid when you have active controllers changing in that way, and instead cue off of just keyboard input. The Steam Deck has capacitive touch joysticks and trackpads, and a great way to use the gyro is to only activate when the player is actively touching one of those cap touch controls. Using both inputs together provides incredible speed and accuracy, but you can still recenter or adjust just by lifting your thumb off the control, much like recentering a mouse on a mouse pad. This is how the gyro is set up by default on the deck. We can also bind the back buttons to be helpful actions here, like jump, reload, slide, or sprint, so the player can keep their thumbs on the primary controls in the middle of the action. This is, of course, just one quick example of how you might expand your existing controls to work on the Steam Deck, but we hope it gives you an idea of how you can potentially make the most of the available controls. So now that we have this set up and tested, to add this configuration to your game, simply save it and then click on the Get Controller Config button in the Steam Deck Devkit app. This will save a local file in the specified directory you can put in source control and distribute with your game. If you saved your configuration to the cloud, the dialog will also provide a link to the configuration. This can then be set in the Steam Input tab on the partner site and activated immediately without shipping any files with your game. You can set multiple configurations for each controller type, meaning the user can easily select whether they prefer standard or motion controls, different layouts, and so forth. And since PlayStation and Switch controllers have excellent gyros, you can support them in the same way. And the same goes for any additional inputs that they have. Any controller types that you've opted into Steam input will automatically get your preferred official configuration by default. Finally, what about the touchscreen? Currently, the Steamdex touchscreen acts as a simple mouse pass-through by default, but it also supports native touch APIs via SDL as well as Windows Touch through Proton. This can be set on a per configuration basis, so if you already support touch, you can enable it in your configuration and bring that functionality to the deck. We're investigating other ways to best support touchscreens, and we'd like your feedback on what would be most useful to you. We hope this gives you a brief look into how you can expand your input to support not only the features of the deck, but a wide variety of controller types that your players own and would love to use with your game. Thanks.
And welcome back, Scott. You are a very popular guy. I don't know if you know this, but we got a ton of questions during this talk. Cool. You pretty ready?
Hopefully.
Yes, you are. Okay, the very first one is talking about Steam Deck having a lot of unconventional controls. And the question is about whether or not Valve will be encouraging developers to integrate gyro and trackpad aiming into their control schemes instead of sticking with the more traditional layout.
Yeah, I mean, I think it depends on exactly what your game is and sort of what sort of controls you're looking to have in there. But we do think that both the gyro, when combined with the joystick, as well as the gyro and the trackpad, are, they're for a big class of games, really great inputs that people will want to use. And, not only from sort of offering higher precision for people that are used to gamepad inputs, but also taking sort of the mouse paradigm of just, people that are comfortable playing on their desktops and bringing that into a portable form factor.
Mm-hmm. A few folks really wanted to know about local co-op multiplayer games and what you can tell us about that.
Okay, so yeah, you can play local co-op on the Steam Deck. You can, hook controllers in via Bluetooth, or if you have like a hub hooked up to it, you can hook them directly in via USB. And so you can play games that way, or, of course, if you have video out going to a TV, playing together on a TV. And then you can also play with remote play together, so you can have those games working where one person's at a different, computer and you're streaming from the deck onto that.
Nice. Okay, the next question is about multiple input methods, and will there be multiple input methods to work with, such as direct input, X input natively, that sort of thing?
Yeah, sure. So the deck supports all the sort of input methods you expect: raw input, direct input, X input. Those will all work just fine through the Steam Deck, or of course Steam input. So yeah, if you're targeting any of those, it'll just work.
Okay. We also got a lot of questions about the touchscreen, and this specific question wants to know if the touchscreen input will be treated as a mouse input or whether it uses a specific API in Steam input.
So you can use both. By default, it will just look like mouse inputs because, generally speaking, for a lot of games, you'll just want to be able to touch the screen and have it be treated like a mouse click. But you can also enable the sort of native input methods that are available in Windows or via SDL, and that's just a configuration option. So if you turn that on in your configuration, that will just start working.
Okay. And will it be possible for developers to create Steam Deck Steam input configs without a dev kit?
Yes. So like if you're working on a game that you're targeting for the deck, you can always use a PlayStation 4, PlayStation 5 controller, or really any controller. But the PlayStation controllers offer the sort of closest set of controls in that they have a built-in gyro and they have trackpad. So you can start getting a feel for those sorts of things. Of course, they won't have a touch screen and they don't have the back buttons, and the trackpad's a little different in its layout and capabilities. But you can get the up and running and sort of start feeling out how your controls will feel without a deck. We do think that to really sort of dial that in, you'll probably want to have a Steam Deck that you use for sort of putting out that final set of controls. But if you're using a subset of the controls where you're not using every single one of those, that'll work just fine.
Oh, makes sense. Okay. Quite a few devs wanting to know about porting. Does Valve encourage games that need mouse interaction to be replaced to Steam Deck's touchscreen?
So if your game is really specifically targeting like a touch sort of interaction, then yeah, that's totally fine to use the touchscreen. We think for a lot of games that are more cursor-based, that oftentimes you'll want to use the trackpads instead because they'll give you sort of easier interactions that people expect from generally cursor interactions. In that, oftentimes when you're targeting a touch interface on like a phone or a tablet, you want to have much bigger hit targets and things like that because your big finger's getting in the way. But yeah, if you're really targeting that sort of interface, then that will work just fine.
And what about latency with Steam input? Is there any extra latency with it?
There shouldn't be, no. If you're working on a project and you do see anything like that, of course, let us know. But it should not add any latency.
And are we supporting the deck as an external controller?
Yes. So you can, right now, currently you can remote play into another machine, and it will recognize all of the deck's controls and treat it as a full set of Steam Deck controls. So you can also test your game on like a desktop PC that way, or just remote play, or have multiple controllers using a Steam Deck.
Okay, great. We just have one more question. That's it. And will we support touch menus on the Deck touchscreen?
So we already support sort of virtual menus like radial menus and touch menus via Steam input in general, via the trackpads or joysticks. We're looking at ways that we can support it with the touchscreen, and we currently have similar things there for touchscreen via like streaming on phones and tablets. But we haven't solidified any real plans there yet.
Okay, great. Scott, thank you so much.
Thank you.
Really appreciate it. And thanks to all of you for all those questions that kept coming in. Now, this wraps up our official talks for the day. But as we've been mentioning, we've been collecting some of the additional questions coming in from all of you. And yes, we are going to handle some of those coming up next. So designers Greg Coomer and Lawrence Yang are coming back in just 2 minutes for that final wrap up. So stay there, don't move. And welcome back one last time to Steamworks Virtual Conference Steam Deck. We've been collecting all of your questions throughout the day and are just creating a bit of extra space to tackle them at the end here.
And designers Lawrence Yang and Greg Coomer are back with us right now, and we're going to get out of the way.
Come on.
Hi, everyone.
Hi again.
We've got about 10 or 11 questions to get through for just ending the day. We're going to dive into those. We're reading them off a screen, so we're going to kind of figure out how to make our way through them. Why don't you start us off with the first one?
Great. Not awkward. Okay. Can you? So one of the questions that's top voted right now is like, can you give us a more specific date about SteamOS 3 and when it'll be available for us to install on our hardware? I'm guessing by this you mean arbitrary hardware and not necessarily Steam Deck development hardware. And the answer to this is like, we don't have a solid date because we're actually still finishing things up on the OS front for Steam Deck's launch. And we imagine sometime after that we'll make SteamOS 3 for arbitrary hardware available soon after that.
The next question is regarding developing without a deck in terms of the operating system. For compatibility testing, should we just use SteamOS, or will there be some locally installable Steam Deck OS image?
And again, so I talked about this in the first talk of today, 3 times actually. But the best option for this would be to use right now Manjaro as per the documentation. And coming up soon, we'll have another image that is closer and includes things like GameScope and possibly Gamepad UI for you to use with your dev machines.
Next question is, when will new countries be brought online? Meaning, when will Deck be available in more territories around the world? We're basically finalizing plans on a bunch of other countries and territories. And although we don't have a lot to announce soon, there are some that are sort of ahead of others just logistically. In particular, we're working really hard right now on Japan and Australia. Before too long, we think we'll have announcements to make, but we still don't really, nothing concrete today.
Next question is, could Valve be interested in having Steam Deck exclusives? I'm reading this as, would you ever want a developer to make a game that only works on Steam Deck? And the answer to that is no. That doesn't really make much sense to us. It's a PC, and we just think that it should just play games like a PC does.
Yep. Next one is, how long until ported and submitted games get reviewed and get feedback on deck?
So
I think that's about deck verified.
This is about the deck verified process. So we actually do also have documentation about this as well. I've been saying it a lot, but it's at the partners site. In case you haven't seen it, there's a lot of documentation there for stuff throughout today's talks. But specifically for compatibility reviews, our aim right now is that within a week of submission, and by submission I mean a partner pushing a button that says, please review my thing for Steam Deck, we think within a week we'll have results available. That said, we think this will fluctuate depending on the current size of and complexity of other titles in that queue.
The next question is, what's up with that Portal-themed white Steam Deck in the background? And will that be available for purchase in the future? Which is sitting here right behind us. No. I'll just show it off more. This is a prototype only. We love it too, but we're not able to bring that to market at the same time that we're shipping the regular Steam Deck. We're going to look at other color options in the future, but that's really down the road, so nothing to announce today.
One question from back in the beginning of the day was, how do we decide who gets a dev kit? Like I said, they are really constrained and limited in number. We have less dev kits than we have developers. So the way we're actually figuring things out for that approval queue is by looking at not only community interest in that title of that developer, but also what are the top games being played by people who have reserved the Steam Deck. And we prioritize those for dev kits.
OK, so next one is, how do we get Steam Deck verified applied to our games and then show up in the Steam Deck store home?
Yeah, so Steam Deck Verified is something that we announced and went through pretty in detail a few weeks ago, 2 weeks ago. And so yeah, there's a whole process. It's pretty similar to the existing build review process that we have in place for just getting your games on Steam at all. But it's just another one of those. We have testers that go through a set of tests that check your game out to see whether it has good input support, whether the display works, whether it has Proton bugs. And based on that, you get a category, you get assigned a category, and if you're in the top category of Deck Verified, you will show up by default in the Steam Deck store homepage. On the Steam Deck, there's also a way to see all the games on Steam as well, including all the other categories like playable and unsupported. So all games will still be available to look at and download and view on Steam Deck. But the ones featured will be the ones who are Deck Verified.
There's another question about the verification or Deck Verified process, which makes sense because it obviously is a new program and it matters in terms of visibility on Deck. The specific question is, what kind of feedback is given in the review report? If your compatibility is playable, will the report say exactly what should be fixed or changed, or something more like, there are just improper controls? And before we answer the specifics of that one, I think it's important to just note that this Q&A session isn't really the primary source of info on this. Like, we're going to be making sure that these items are covered in our documentation. Some of them already are. But we'll give you the basic answer here, which is that there is a more detailed report, right?
Yeah, there is. So right now, there's basically progressive disclosure. At the top level, you'll see an icon, and customers will see an icon for which one of the 4 categories it falls into. You'll be able to go into detail and see like which items within each category it passes, fails, or is playable on. And for developers on the partner side, we're actually building the tool right now where you get the results of your review process, and on that there will be an additional string where our testers will be able to tell you with a little bit more detail how exactly the thing failed or did not fail, if it's relevant to that item.
Yep. I think as we've been talking, there's another Deck Verified question coming in. The question is, will it show up on store pages when browsing from a PC or other non-DEC device? What that means is, will the rating that Valve applies to any given game appear in the store context if you're not looking at the store from a DEC itself?
And the answer is, if you are someone who owns a DEC and you go to the desktop version of the store, you will see an extra little row on the game detail page. And you also see it in the search if you search for different DEC verified statuses. And that search aspect is also available for everyone, even if you don't own a DEC. So the high level answer is usually no. We think that it's definitely important when you're on DEC to see it in the store. When you're not on a DEC and looking in the store, we think it might be somewhat useful if you do own a DEC, but otherwise we make it available, but we don't put it in your face.
We've got another question about game engines, specifically the Godot engine. Basically, people are wondering whether we are talking to them or supporting them, and the answer is definitely yes. We're very interested in it and just having that engine work well with Steam Deck. So we're already talking to them and definitely actively interested in supporting them.
Another question about how many sound channels DEC supports. And it looks like we support 2 when using the onboard speakers, but we support multi-channel when using HDMI or Bluetooth output.
Which makes sense, because there's only 2 speakers.
That makes sense.
I think this is our last question of the day. Looks like it's, will there be a way to install external apps on DEC without going into dev mode? That's definitely yes.
Yep.
There's the method by which you do that. It can be a Flatpak or other software, other methods will definitely be installable without going into dev mode. There are some caveats for how persistent are the things that you install and the methods by which you might need to do that, but it's not like you need to enter some secret developer mode to do those things. Even on regular user side, that's going to be very accessible to install things that are not coming from Steam directly.
And
I think that's
it.
I
think that's our last question. And we're going to bring
thanks very much. Casey and Eric are coming back.
Kicking you out of here. All right, that just about does it for Steamworks Virtual Conference. It's all about Steam Deck. We really appreciate you giving us your time, and we're really looking forward to continuing to take in feedback and work with developers towards getting games running great on Steam Deck. The site with documentation links will continue to be live, so you can come back and reference those anytime you want.
And if you missed a talk or two, don't worry. We're going to be posting those in just a little bit. And the team is also going to go back and gather some of your most asked questions today, even if we already addressed them. So we're going to try to collect them into one place for you to reference. Huge thank you to all of our speakers today, to AMD, to our production crew. On behalf of Valve and the Steam team, I'm Casey Aitchison-Boyle.
And I'm Eric Peterson. We're looking forward to getting Steam Deck out to customers and to working with you all along the way. Thanks again, and take care. We've got lots more to come.